All right, is everybody able to see my screen at this
Yes.
point?
Yes, we can see it.
Yes.
All right,
Yes.
so this is the intro to data-driven projects. Just sort of brief introduction that I've put together. Both Sandeep and I sort of work in the area of data science and data analytics. And as Sandeep mentioned, we kind of wanted to be able to share a bit of our knowledge and also bring in some people from the outside um, to lend their knowledge. So this is just the first session in what we hope will be a series, and it's just an introduction. So what we're going to cover today, so the outline is basically what is a data-driven project, and then the roles of the people who would be working on a data-driven project. And then we're going to go over the CRISP DM model of data science. And we're just going to go through everything step by step. Again, any questions, feel free to let me know. So first of all, what does data-driven mean? Being data-driven basically means making decisions based on data analysis and data interpretation. So right now there's more data available than there's ever been before. And companies are collecting data all the time about their products, about their customers, and it enables them to analyze that data so that they can make their products better and better tailor those products to their customers. So then what's a data-driven project? It's basically a project that uses data to gain an understanding of a process in order for decisions to be made. So data analysis and interpretation play key roles in data-driven projects. So in order to delve into data analysis and data interpretation, if you work at a company or even kind of in academia like myself, you'll probably be working on a team, either of data scientists or with colleagues. And especially within industry, data-driven projects are assigned specifically to data science teams. And the teams are typically made up of individuals that have four main roles. And those roles are data analyst, data scientist, data engineer, and machine learning engineer. And there can be crossover between these roles. And in smaller companies, sometimes an individual can kind of wear more than one hat. But if you're working at a larger company, the roles will typically be divided this way, or they can even be subdivided and even more specialized than this. So what exactly does each of these roles do? So a data analyst generates reports and visualizations and then provides insights based on the results of analyses. So the analyst would just be looking at the basic data, would do some quick analyses, and be able to provide some some actionable insights with a fairly short turnaround, usually without the use of things like machine learning or really heavy statistics or mathematics. Whereas a data scientist um, relies heavily on mathematical models and uses a company's data to make predictions. And in order to make these predictions, the data scientist needs to be able to build machine learning models. The data engineer sort of works upstream, where he or she will design, build, and test pipelines to clean and load data for analysis. And then the machine learning engineer would work downstream, where they would optimize the pipelines that might initially be built by the data scientists to train, model, and test the performance of the model but at a larger scale. So where you're not just running an analysis and fitting a model with one set of data, but this might be happening on a continuous basis over the course of months or years. So really, in order, the data engineer would feed data to the analyst and the scientist, and then the machine learning engineer would sort of work in concert with the data scientist and sort of downstream of the data scientist. So just kind of saying that makes it sound like they all kind of work on top of each other and around each other. But there is a sort of common industry standard process that they generally follow. And I'm going to get into that in just a minute. First of all, you might be wondering what skills you need in order to perform each role. So the data analyst relies more heavily on data visualization and communication. They need to be able to program in order to produce visualizations. And they use a bit of statistics. The data or the machine learning engineer, on the other hand, needs to know how to program. They need to know statistics. They need to know a lot of machine learning. And in order to sort of feed into this machine learning, they need to know a lot of calculus and linear algebra, because that's how these models work. The data engineer uses programming tools, needs to know how to wrangle data, needs to know some software engineering. And the data scientist is kind of like a bit of a jack of all trades, and might, it's kind of like an interface in between everybody. So this common process that I was talking about is basically how the individuals work together in these roles to complete the project. And they generally use a model that's called CRISP-DM. That stands for the Cross-Industry Standard Process for Data Mining. This is the most widely used data analytics model in the world. It was developed in the EU, but it's used pretty much everywhere now. And it's not just used for data mining, but it describes the entire process that gets used for working on data-driven projects. So everything from understanding the project at the beginning to mining the data to building production models down at the very end. And this model is broken into 6 general steps that can be performed iteratively. So they're often represented in a circle, and this is what it often looks like. So when you get the results of one project, that can lead to better understanding and potential new projects down the road. So the first step is business understanding. The second step is data understanding. And as you can see, these arrows kind of go back and forth because once you understand a business case or a problem, you then have to go and understand what data you have to work with, which will then inform your business understanding even more, but might lead you to realize that you don't yet have enough data. And so you need to get more data, in which case you'll have to go back to data understanding. And this can kind of be an iterative loop that goes on. Data understanding then typically feeds into data preparation and modeling. And this, again, is an iterative process because I guess you need to prepare data slightly differently or engineer your features slightly differently, or you may choose to, depending on the type of model or models you're going to build. And so you will have to prepare your data in several different ways. And then once you build your model, you can evaluate it, and that will lead to business understanding, and you can deploy that then at scale. So delving a bit more into the different steps, the first step is business understanding. And this is the part of the project where you really determine your objectives. So if you work at a company and your supervisor comes to you and says, well, we want to get more customers, or we want to retain the customers that we have. This could be viewed as a data-driven project if your company is collecting information, say, on the customers it has, maybe on what the customers that you currently have buy, and you sort of have to formulate this into a business problem. And you can do this by finding background information, like, say, what kind of information does your company have on the customers that it has? Like, does it have information such as their ages, or where they live, or how many transactions they've performed? And then you assess the situation, like, what exactly is this calling for? You have to evaluate the costs and benefits. You might want to build, a huge machine learning pipeline with really, um, I guess, in-depth neural network models, but given the scale of data that you have, that might not be practical if you're going to do that on premises with the computers that you have. So you really have to know what it's going to cost you and what your company stands to gain from the work that you're doing, and how is your company going to gauge your success. So are they looking for a 5% increase in customer retention, or maybe a 10% increase? How exactly are they going to decide whether you've been successful? And then you put all of this into a project plan. And this isn't necessarily exclusive to business. You can apply this to any type of data-driven project that you would want to work on. You don't necessarily have to be looking at retaining customers. You can say want to gain information or want to predict how say COVID vaccine uptake is going to proceed around a certain area. And you would still need to perform all of these steps, like finding background information, assessing the situation, evaluating the costs and benefits, defining the success criteria, and creating a project plan. The next step is data understanding. So this is the part where you collect your initial data. You then perform some preliminary analyses to describe your data and understand it, and make sure that it's quality data. So do you have a bunch of missing data? Is your data accurate? Is your data, maybe your data is collected from a bunch of people that were taking measurements that might have recorded the measurements in different units, or it was recorded by weather stations that might not have been calibrated properly. It's really important to ensure that you're using good quality data at the beginning, because otherwise any model that you build downstream is not going to produce quality insights. And this step can either feed forward to data preparation or back to business understanding. So you might find that once you've collected your initial data, you don't have enough data to perform your analysis, but then you understand your business case better, so then you come back to your data understanding again. Or you can go downstream to your data preparation. And this is a step where you, as a data scientist or a data analyst, you often spend a lot of your time. So you've got a lot of data. You need to clean the data. You need to perform feature engineering. Like if you're building machine learning models, machine learning software doesn't handle missing values very well. So you might need to figure out how to deal with that. Or it might not handle, you might want to convert your categorical data into like one hot encoded data. You might want to integrate data from different sources and then ensure that it's all in the same format. And then each time that you integrate new data, you have to kind of go through this process of cleaning it again and making sure it's in the same format, and then making sure that it's scaled properly and properly standardized. And as sort of unglamorous as it seems, this is where I typically spend a very large proportion of my time just kind of wrangling the data. And then once the data is prepared, you can get to this what's arguably the more fun part, which is the modeling. So you figure out what kind of modeling algorithms you want to use, you build the models, you evaluate the models, and then you might need to move back to data preparation again in order to re-engineer the data, kind of decide to include or exclude certain features in order to complete modeling. Every time you build a model, you need to take a look and see how accurate it is. So it's sort of not a process where you build a model and then you're done. You need to build many models and then compare them to each other, and then figure out what the best one is for your purposes. And this is something that we're going to be covering in a future session. The fifth step is evaluation. So in this step, you really look at your models in terms of your business success criteria. So does your model, like your best model, or your most accurate model, predict that by making the changes that you've decided on, you're going to achieve that 5% increase in customer retention? And if not, what can you do to change that? You might not know, but you might be able to make an educated guess based on your really in-depth analysis of the data. Just kind of getting to know it very well gives you a sense of intuition sometimes about which features are more important and which features are less important, and that will enable you to determine what your company might want to focus on in the future, even if your model states that the given changes might not achieve the desired target by a certain margin. And then the last step is deployment. So you've done all of these things. You've worked really hard with your team, and so you plan the deployment of your model. So ideally, you would build a model, and then you would want to run it sort of continuously to determine whether you are achieving the success that you planned for. You would produce a final report that would include everything that you did, would include links to the code that you wrote, would include links to all of the data that you gathered, and would include a review of things that worked and didn't work in the entire project. And So if that seems like a lot of work, that's why there are generally um, several people on your data science team. You don't just have sort of one person that does absolutely everything. um, so I'm gonna stop there and ask if there are any questions.
Hi, Aaron. I had a quick question about one of the slides that you showed earlier. It was kind of like a skills matrix for the different four roles.
Yeah, I can go back to that just a second.
Sure. Yeah, thanks for bringing that up. I just had a quick question about the data scientist skills. So I noticed that, of course you need statistics for that role, but you put down like multivariate calculus and linear algebra as kind of like a medium sized circle. Um, like as a data scientist, like you're not a machine learning engineer. Like you're not developing new algorithms. You're like applying existing ones like AutoML or scikit-learn or something. So like how would calculus and linear algebra like help a data scientist like improve their ability to perform a task?
So, having an understanding of how the like how the different algorithms work, is really important when it comes to, first of all, selecting what algorithm you might want to use. Um, so, are you going to use linear regression? And if you're going to use linear regression, are you going to use like ridge regression? Are you going to use like lasso regression? Are you going to use like there are a bunch of different um, I guess types of models that can be built, and I think there are more that are being created all the time. Um, I think that this comes in, or this is particularly important when it comes to what you call um, hyperparameter tuning. So um, if you understand the um, how the different machine learning models work, there are certain parameters that need to be fed into the model at the beginning that aren't changed over the course of um, fitting the model. But you will need to understand how the model works in order to be able to select appropriate parameters for that. And um, the better you understand the model, the better you'll be able to select those parameters. Um, you'll also be able to, I guess, converge at or it might enable you to converge at um, an optimal or a more optimal solution more quickly in terms of a model. Like you can develop more intuition about which type of model will work and which type of model won't work for a certain problem with a certain type of data. And you will know what you need to do with the data in order to be able to feed it into a model to get the model to fit properly and work. Hopefully that makes sense.
Yeah, I think so. Like the way you explained it. So having that particular skill set is not necessarily, you wouldn't need it to develop an algorithm. You would need it to, put you in a better position of choosing the best algorithm for the data that you're need to analyze. Is that like a good summary?
Yeah, and I mean, if you are going to go and develop your own machine learning algorithm,
Yeah.
then
Yeah.
you definitely need that skill set. And so if you're working at a company like Google or Amazon that actually develops its own machine learning algorithms, then you definitely need that skill set in order to be able to um, know how existing models work and how to improve on them, um, and implement sort of an idea into code, um, by through calculus and algebra.
Okay. Thanks so much, Aaron. Appreciate it.
No problem. Does anybody else have any questions? Okay, I'm going to move forward. Oops. I think I've just got, um, this was just, so this particular presentation was just meant to be a sort of gentle introduction to data-driven projects and the CRISP DM model. The next meetup that we have will be more in depth. So um, I'm this presentation isn't super long, but basically, as I was saying before, personal portfolio projects can also be structured um, using the CRISP DM model. And I do this myself. And instead of using business understanding per se as the first step, you can focus on just determining the objectives of your project. Like what do you want to achieve through your projects? Um, and then if you go through all of the steps, it sort of ensures that you're not going to miss critical steps. And um, it will also give you a lot of experience wearing the hats of all of the roles that um, the individuals in a data science team would have. So building sort of portfolio projects that are data driven can be really helpful also to help you find out what parts of the process you like better, and which parts you're best at. And that might help you determine where you want to sort of focus your efforts if you're looking at making career change down the road.
Hey, Aaron,
Yep.
I have a question. If you're comfortable, would you mind sharing an example of a personal project that you use this model for? I mean, just you don't have to go through the whole thing, but just like what kind of project was it?
So one of the projects was a an exploration of um, um, looking at how or at vaccine uptake for COVID-19 in British Columbia and how it differed by area and by demographic, sort of with the hope of identifying demographics or areas that could be focused upon for vaccination campaigns in the future.
Oh, cool. Okay.
I think I have a link to it on my GitHub. And if I don't, I should, and I will make sure that I do very soon.
Okay, cool. Thank you.
No problem. um, so this is the last slide of the presentation, and I guess we're about 12 minutes to 7 or so. Does anybody else have any more questions that I can answer, or any comments, or even if you just have a feeling for areas that you might like to see covered more in future presentations?
I think, and I don't know if anybody wants to pitch in, feel free, but this presentation, the CRISP DM model, I was not aware of that. I was working in the industry, and now that I look back in my past, all the projects that I have done follow the same process. You start with a business understanding, get some data, prepare it, and then follows the entire cycle. Obviously, with data science, this model development is the new aspect that is out there now, but basically I was not aware of that, so thanks for introducing me to that. But yeah,
I I honestly I had thought that it was like really pervasive. But I didn't know that, Sandeep. Interesting.
yeah, I wasn't aware of that, and I haven't maybe never heard of that before, so yeah, new for me.
Well, I'm glad I could share something that could be helpful in the future.
For sure, yeah.
So I'm going to stop my screen share now, and I will stop the recording.